Assalamualaikum warahmatullahi wabarakatuh, and my name is Muhammad UNAIS bin Akbar. I am hereby going to present about CRISPR-Cas9, a brief overview on a revolutionary technology. Alright, so let's go. So the introduction, this tool is a technology that will edit the instruction manual of life, which is the DNA itself. Okay, so our DNA is the instruction. Okay, it's like the instruction. It gives instruction. Sorry, it gives instruction to our body, pada badan kita untuk buat protein dan sebagainya. Kan? So CRISPR-Cas9 ni, it is a scientific tool that can allow scientists to go into this instruction book, which is our DNA. Okay, and find the exact error and cut or fix it because we want to fix the gene so that we can treat genetic disease macam sickle cell disease, alright, ataupun kita nak treat HIV menggunakan RNA, okay. Dan CRISPR helps in locating the fault part of DNA, while Cas9 is the scissors that cuts it. Okay, kalau nak tahu macam mana, kita kena pergi kat slide seterusnya. Alright, so this is the mechanism of action of it. Okay, so first we need to create the guide RNA. Okay, it's like the GPS. Alright, scientists create a small piece of RNA called guide RNA. This guide RNA is like GPS or search tool. It is designed to match and find the exact location of the gene that causes a disease in the DNA. Alright, we create a RNA sequence, so we edit it so that it can match with the genes that we want to make the difference, we want to edit. Alright, and then we insert it into the patient. And then the next one is Cas9, the scissors, a special protein that acts like molecular scissors. The guide RNA leads Cas9 to the right spot in DNA. So the next one, of course, we already know the match. Alright, so the Cas9 will cut the DNA at the exact spot. Think of it as a cutting out type of word out of sentence. And then after cutting, what happened? Fixing the DNA, of course. The cell tries to repair the damage, but during this repair, scientists have dua option. Kita ada dua option. Sama ada kita nak close the gap, alright, so that we can deactivate the sequence, specific sequence, ataupun we can insert a new piece of DNA, alright, a healthy DNA, a DNA that don't have any gene mutation. Okay, alright, so here I like to share a case study involving CRISPR technology. It's about a 27-year-old man had both HIV and blood cancer, a very bad condition. So doctors use a special gene editing tool called CRISPR to try and make his immune system resistant to HIV. So they took blood stem cells from a healthy donor, from a healthy person, and they edited them to remove the CCR5 gene, which HIV needs to infect cells, and transplanted them into the patient. So the patient's leukemia basically went into remission and stayed that way for over 19 months. Alright, however, not enough of the edited cells survived, so HIV was still present when they paused his HIV medications. The procedure was safe overall, with expected side effects and no major complications. Okay, so they stopped the medication because the edited cell, not enough edited cell was survived. So, but what happened after that? Okay, the patient stopped HIV medication for 7 months. Okay, after the transplant, to test if the edited cells could control the virus. Okay, at 4 weeks, the virus came back very high levels. Okay, so this shows, okay, so that medication really did something to this person's immune system, right? Because when we stop it, suddenly rise back. And then the HIV medication they started back and the virus dropped back to undetectable levels after restarting the treatment. The number of HIV resistant immune cells with CCR5 removed peaked at only 4.39%, which was still too low to fight HIV on its own. Yeah, so there is a brief story of a clinical case study on how scientists use doctors use this CRISPR technology to help a patient immune cells to be resistant to HIV. So the broad use of this CRISPR technology is very big, very large. Like we have a very big scope of using it, but it depends. It needs some ethical concerns too, right? So this a brief explanation of why it may work or it may not work, right? So the HIV T cell, okay, it will come inside here, and if only single gRNA CRISPR therapy happens, it still can escape. Although it have some changes, but it still can escape. But if we want to cure, okay, we need dual gRNA CRISPR therapy for it to be cured. So this is can't be fully controlled, but uh, it do makes an effort and makes it better based on the clinical case study that have been done by the doctors and scientists. Uh, and now my conclusion and personal opinion on this technology. Okay, for me, when we playing with the genes, it is like something natural. It's something that already we have, and it is a part of nature. So it's like playing the role of God, right? Yeah. So gene editing technologies like CRISPR give us the unprecedented power to change human DNA, not just to cure disease like HIV or cancer, but potentially can reshape human biology itself. So this is where we really concern. From a religious perspective, this can be quite literal. Okay, imagine humans exercising a level of power that only God should have, or changing divinely created nature. So we must make sure we have a strict guideline if one day this technology is have been published and been said that it is reliable and can be used. We must make sure that it has uh, really strict guidelines, okay, that limit the use only to cure it, right? To cure a disease that can be a life changing to someone, then is okay. Related secular concerns center on exercising power that we cannot fully foresee the consequences of, and human arrogance in relationship to nature. Okay, and humans have greed and will never be satisfied. The reason I put this is because every one of us want to be perfect if we can, but in this world, we it has biodiversity. Alright, everyone is different, and that is what make this world balanced through its nature, through its ecosystem shape and healthy ecosystem. So maybe we don't know, maybe we can disrupt this nature with something divinely created by God by using this technology, right? So that is what my opinion is. As long as we use it to cure a specific disease and not for our own greed or our own uh you know our own greed, yeah, then it will be a wrong thing to do. So before I finish my presentation, I would like to present this question to you, to every audience that is watching this video. So you can think a question that will make you think. If we have the power to edit a person's gene to cure disease, where do we draw the line between healing and changing what it means to be human? Okay, so this is a very open-ended question that every one of us will have a different answer, right? So this is my question for you, for everyone who is watching this video, and I hope you learn something from this video, you get something from this video, and I hope it is beneficial. Alright, so thank you. That is all for me, and Assalamualaikum warahmatullahi wabarakatuh. Bye.